Welcome to the section on training and optimization. In this section we shall train this model which we've defined previously. Right now we have this. Our losses sparse categorical across entropy because our output is this 20 by 10,000 tensor right here, and then the data we're receiving is of dimension by size by 20. So we're comparing this with 20 to 10,000. So in order to compare this and to apply the categorical cross entropy loss, we're using the sparse categorical cross entropy loss. Now if our outputs were built such that we'll have the one hot representation, then in that case they will be like this, and then we'll not have to use the sparse, we'll just have to use the categorical cross entropy loss. So that's it. We now run this one right here, take this off, and then we'll train on our validation set. Recall the validation generator was defined previously right here. We had the train generator and then the validation generator. Now all it suffices to do this, in order to do this, it suffices to just specify this folder and then call the data generator based on this folder. So that's it. We can now start the training. We are getting this error saying that there is an expected dimension 10 at axis 0 of the input shaped 5, 14, 16, but got dimension 5. Now if we look at this, it should have to do with our data generator. So let's get back to it. Now the problem here is that when we have a batch size of, like in this case we've picked the batch size of 2. In the case where we have a batch size of 2, what we're defining here is this x of dimension 5 by say the 224 by 224 by 3. But note that since we have a batch size of 2, instead of having 5, we should have 5 by 2, that is 10. So this means that we have to multiply this by the batch size. That's it. So that should be fine now, instead of just multiplying it as if the batch size was equal 1. So let's run this again. We can increase this batch size to 8. So we could have that, run this, and that's fine. Now let's go ahead to train our model. We have another error. Let's get back to that. Modify this batch size here to small letters, batch size. Run this now. That's fine. After training over several epochs, here are the results we obtain. Let's pause the training and then go ahead to test our model on this small part of the validation data set. We define this function caption, which takes in the image. As you could see here, we have this model. It takes in the image. This is the image right here, which we pass in. And then it also takes in the shifted output. Now we have the output. We include the start token. In this case, start token is 75 plus or 75 concatenated with all zeros. That is basically just padded. We pass this in, and then we have the model predict or give us an output. Once we have this output, we have the argmax to get the highest values at each position in the sequence length. Now if this output, or if at any given time we have an output of 0, we just get out of the loop. Then here we implement teacher forcing by taking in the output and feeding it back into the pre-output. Then we have this final output which contains the different outputs. So that's it for this caption function. Now we can test our model on this image. We see right here that our output is just A, but based on the results we had when doing the training, we shouldn't have this kind of output. This means that our code has some errors. Now to look at this quickly, let's go ahead to create this custom loss. We have our custom loss, which takes in the y true, y bread. So basically here we're repeating this, as we are having the sparse categorical cross entropy loss, but now we want to print out the y true and then the widespread every time. We just pick out of the whole batch, we pick out just the first. So yeah, we could also pick out the first, and that's it. Now we're gonna print this out and print this out too. So let's run this now. Run this. Oh, we see that this is what we get because we are not in the eager mode. So let's get out of the graph mode and get to the eager mode. In graph mode, we could use tf.print. Anyway, to go faster, let's use the eager mode. Yeah. Okay, so let's now get to the top. Let's reduce the batch size. So let's take 2 so that we don't waste time while doing that debugging. Take this off. Now let's run this again. Get to our model. And there we go. We have this y true, which is this. This looks a bit funny because normally we have no output or no caption which has only one word. This tells us that there is an error right here, and we see that we have to understand exactly what's going on and what's making it that some of these outputs come up like this while some of come out normally. And also, if you want to check on that to know exactly the outputs you get, you could simply take this. So let's stop that. Let's get to our data dictionary and have this here. So we get that ds, let's say 0. Okay, so we see that this is what we have. Now if we have for I in range 5, we're gonna print this out. So yeah, we have ds plus string of I. Okay, close this up. So we see that all our outputs are like this. There is no output with just one word. And if we have to look at that, to tokenizer dot index to word of 2. So what is telling us that it most probably is working with just this, and then this one is selecting just this word, while for the others we see that it takes all the words. Like let's take this example for the y true. Let's get back up. The y true is actually the first, so this is y true, this is y pred based on what we print out here. So this y true, yes, y pred. Recall that the reason why we're doing this is because the y pred shape is different from that of the y true. The y pred comes as a 1-hot vector, while this doesn't come as a 1-hot vector. That's why we need to do the argmax on the first axis. So if that's okay, we now look at this y true, y pred. Yeah, y true, yeah, y pred, y true, y pred, and so on and so forth. If we take 299, 17, 78, you'll see that if you have to do 2a, then 90, a crowd, 9, 78. Yeah, so that's normal. Now let's get back to the data generator and try to print out some of these captions to better understand what's going on. So right here we'll have this print the caption. After printing the caption, the next thing we'll do is we also print this tokens. So we'll try to print out these tokens here. Now let's stop the training, run this, run this, run that, get back to this. Now we've understood this part, we could just take off this custom loss. We don't need that. So this, take this off, run this. We have an error. Okay, yes, TF. So run that. Let's get back to the top and correct that. So here we have this caption. This should come after this. So we'll print out the caption. Take that off. That's fine. Now we get to see exactly what's going on. We have the caption, we have this cap sequence. We see that there's a problem here, and that's exactly what we're looking for, because we see that all this normal, but at some point we have this abnormal output here. Now let's look at this closely. So we can situate where this error is found. Now let's go again and print out the output from the text to sequences. So let's take this from here. Let's actually separate this. So let's take, we have cap sequence. So yeah, we have cap. Okay, now let's print out the cap sequence. We could take this off now since we print out the cap sequence. We now stop the training, run that. Let's check this. Okay, so this is what we get. Let's look at this closely. Go slow. You notice that there's this list here which is empty, and because in this modification here of the cap sequence, or in this conversion of this cap sequence from a list, because this is actually a list, from this conversion from a list to numpy array, if we have that empty list, then it should pose a problem. Like suppose we have, let's take an example. So suppose we have a equals 3, say 8, and then we print out numpy.array of a dot transpose. Let's correct this here. Okay, so that should be fine. We print this out. Open no training. Let's take this off from here. Run that. We see that this gives us this empty list here. Whereas if we had a value, you see that looks quite different now. So this means that we have that empty list which has been generated, and most probably it's been generated because if you look at this example here, you see that whenever we have this comma, our tokenizer takes this off because this a punctuation sign, so it takes off the comma. Recall that we had this here. Let's go back to the creation of the tokenizer. We have this filters right here, and the comma happens to be part of that. So it means that anytime we're gonna have that and that there are two spaces, obviously we're gonna create now two spaces instead of just one. Another example we could look at is this one right here, where we have two men are using long-handled push brooms. Now this push brooms is separated by this hyphen, and this two will pose a problem if left as is. So that said, let's look at a way to solve this problem. Instead of letting all the filtering be done or allowing only the tokenizer to do the filtering, what we could do is, after this caption, we do this filtering. That is, we convert all the punctuations to an empty string using the translate function and passing this dictionary into it. Now let's see exactly what this dictionary outputs. Let's copy that and print out this dictionary. We have this. Now this dictionary actually links this different characters to known. This simply means that if we have a character, say 33, you see a 33, which happens to be this. Let's look at that. Now let's print out the 33 character. So if we have this, that is this exclamation sign, we convert it to a known. So it's basically it becomes an empty string using the translate function, since this translate function takes in a dictionary. Now if we have 34, you see is this 35, 36, 37, all of that, 126. You see basically that these are the punctuation signs which we want to take off. So that said, that's how we remove this. But we don't only let the tokenizer do the job, we also do this removal before or pre the tokenizer's filtering, so that we don't have the kind of errors we've been having. So that said, we could take this off. We run this part, we have caption, okay, that's fine. Run that, run this, and that's fine. Now we also forget to put this, so let's suppose we have a caption like hello world, how like, let's print this out so you see exactly what it outputs before continuing with the training. Let's print out the caption. So print this out. Okay, so there we go. You see now we have hello world how like. So basically this now has been taken off, and this too has been taken off, and then we could now pass this into the tokenizer, knowing that we don't have to worry about cases where this generated cap sequence may have errors. Before continuing, let's consider this other example here. Suppose that we have this example where there's a space before the comma and then there's a space. If we run this, what we get is this with this double spaces. Notice that this is one space and then double space, unlike previously where if we did this, you'll see you just have a single space. Now we have this double space, and it turns out that working with this double space will be problematic, as some cap sequences will be generated with an empty list. So to solve that problem, we simply go through the cap sequence, and if there is an empty list, we remove it. So that said, we could now run this again. Let's take this off, run that, run this, and then go ahead. We start with the training. Everything now looks okay. Before here is fine. Now let's look at this where we had the spaces. You see that all this empty lists, you see that it's taken off now, and this was because we had double spaces. So here we have this 11 then followed by 3. This is now taken off. Then if you look at the true y, that's the target y right here, we don't find values where we have the first and the rest are all zeros. That's simply because we've corrected the errors which were causing that problem. Now we could go ahead to take this off. We'll go back to graph mode, take this off, and then here we remove this prints. Then another error we have to correct is the fact that here when we define this x, we aren't adding this image arrays into the x as we move from one image to another. So basically to correct that, we just have to do this im array. So as we go from one image to another, we add that up. Now we could take this out, we rerun, and then we train. That's fine. Let's stop the training. After training now for several epochs, we see we're getting the results, and then we could now start with testing. There we go. We have this a crowd of people at an outdoor event. If we copy this and then try to get this exact output from the data dictionary, we should have that same predicted value, a crowd of people at an outdoor event. So that's fine. Now let's look at this other one right here. Run this. We have a group of people at a kitchen table drinking and playing cats. We have that unknown. Let's come back to this. Let's see why we have an unknown word there. Run it again. So let's look at this. We have a group of people at a kitchen table drinking Guinness and playing cats. So most probably this Guinness is greater than, or the index of the Guinness is greater than 10,000, since from the beginning we had selected the first 10,000 words in our vocabulary. Our max token is 10,000. Let's get back to that and then find the index for Guinness to be sure of the reason why we have an unknown generated right here. So we have now tokenizer dot word to index, and that is Guinness. Run this. We obtain this key error, which is normal because our vocabulary having only 10,000 words doesn't contain the word Guinness. So that's why we have this unknown right here. Nonetheless, we've overfitted on this small part of our validation set, and then we're now ready to train on a full data set.